Okay, in this last video, which should be the shortest of the bunch, we're going to take a look at NPV and XNPV. So these are going to be two very important functions that we'll use consistently over the course of the class. So an NPV is useful for a series of cash flows. Here's one very important thing, and we'll look at it when we do the calculation in a second in Excel. It's very important that you do not include the cash flow at time period 0 in the function. That is not appropriate. The Excel function starts discounting the very first cash flow that you highlight, and anything that occurs up front at time period 0 should not be discounted. So we're going to look at how we would do the NPV for that same investment we talked about in the last video, where we were looking at the IRR example, and that is we have this upfront investment of $200,000. We're buying a property for that amount. We're going to have cash flows for years 1 through 5 of $20,000 per year. And then we're going to sell the property at the end of year 5 for $260,000. The last thing we'll need for this calculation is a required rate of return, or a discount rate, and that will be 12.5%. So let's jump over to the Excel and look at how we would do that. So it's over here in the left side, and again we've got the cash flows, $200,000 as a negative upfront cash flow. We've got 4 20s, and again we've got the $20,000 plus the disposition amount of $260,000 that makes up the grand total of $280,000. To do the NPV calculation in Excel, we're going to use the NPV function. So the arguments are first the rate, the discount rate, and then it has values, and it's a little bit confusing because it has value 1, value 2. The best thing to do here is just highlight all of the values except for that very first value, that time period 0 value. I shouldn't say the very first value. Anything that's at time period 0, you never would highlight that, because the Excel function, the NPV function in Excel, discounts the very first cash flow that you show it. If it's an investment that you make up front, you're starting this investment again at time period 0 to follow conventions from your finance courses, we're not going to discount that because it's already a present value. We're not discounting it any further. So what we're going to do is at the very end add back in that cash flow so we have a full net present value. So the way we do this again is have that rate. We're going to go over and highlight all the future cash flows, years 1 through whatever, and then we're going to close the parentheses, and at the very end add in our upfront cash flow. So we would get in this case a result of $15,493, and the slide shows you the similar kind of arrangements. This one has the cash flow separated by commas. I'm not a big fan of that. It's better to, in Excel, highlight the cash flows, but the important thing is, again, you're going to have to include cash flow 0 kind of outside of the formula. We're not going to include that. That's the number one mistake students make, and if you want to not lose easy points, then avoid that simple error. Any cash flows at time period 0, put those outside of the NPV formula. Lastly, let's look at XNPV. Like XIRR is to the IRR function, that's the same thing XNPV is to NPV. So we can do the same cash flows, but now with the XNPV function we can allow those cash flows to be happening or occurring at different intervals. So no longer do they need to happen every quarter, every year, etc. We can have those cash flows occurring all over the place at various intervals, various different times across the investment horizon. So we're going to look at an example here. Let's just jump over to Excel and look at this example I've put together. I've got cash flows. Oh, this is unfortunate. Well, these are cash flows that are occurring every year, and I've labeled the years, so January 1st of each year over the next 6 years. And I guess I want to look at here the difference between the NPV and the XNPV. And with the NPV, I'm going to just highlight those future cash flows, use the discount rate in this case of 10%, and then we're going to always add back in that time period 0 cash flow. In this case, it's $100,000 that you're investing up front for those future cash flows. With the XNPV function, I'm going to, like the XIRR function, I'm going to highlight the values and then the dates. The first thing is the discount rate, so that's going to be 10%. Then I highlight all of the values, even the time period 0 value. and then I'm going to highlight the dates. So again, this is a little bit simpler of a function to use because you don't have to remember, oh, which one is time period 0, which one do I exclude from the NPV function. You just throw everything into the kitchen sink. So it's an easier function to use. One might notice that there is a difference between these two cash flows. It's not a huge difference, but it's enough to kind of cause maybe a little confusion. The reason is the XNPV function is using actual dates, and so because there's a leap year involved in here, we've got some extra days and it's kind of messing up the calculation a little bit. So I'm just going to adjust this real quickly and say 365 days after our very first date is this next date. I'm going to copy that formula across. So now there's intervals of 365 days instead of the first of every year. So we're kind of ignoring the effects of that leap year, and you can see that these two things work out exactly correctly. Again, I prefer the XIRR and the XNPV functions, so anytime you can use those, anytime you can include some actual dates or even make up some dates, those are going to be handy functions to use, and they're in my opinion simpler to use than the IRR and the NPV functions. So I'm going to stop there. That is the Excel review for time value of money. We've got a few functions that we have learned about, so the XIRR, XNPV will be important over the course of the semester, and that will wrap up the time value of money review. So I will see you in the next set of videos later on.